Here we have a word problem with a quadratic function. We have muzzle velocity is going to be the speed of projectile, and we're moving the muzzle of a gun, or in this case a cannon, is going to be given by this position function s of t. So we're looking at t seconds after we launch something, what the height is, and it looks like we're measured in feet. So we're plugging in seconds, and we're getting out feet. So we're doing some zucchini that we're projecting out of here. It says, how high was zucchini initially? So we have our human cannonball, we have zucchini in there, and we're sending him out as a human cannonball. Initially, for anything, no matter how strange the word problem might be, is whatever times 0 is. What's the initial height? If we plug in s of 0, we'd have negative 16 times 0 squared plus 36 times 0 plus 6. So initially, he's 6 feet off the ground. The cannonball isn't flat to the ground. It's 6 feet up in the air in the cannon. If we look at s of 2, we're going to replace all of our t's with 2's in here. So we have negative 16 times 2 squared plus 36 times 2 plus 6. And we want to see what that y value would be 2 seconds after launching our human cannonball. We are going to have him up 14 feet in the air. So our interpretation is after 2 seconds, and he has kind of a long name, so I'm just going to do his initials, EZ, for this Emmanuel Zucchini, was 14 feet high. So he started out at 6 feet, so that was the height of the cannon, but 2 seconds after he's launched, he's up to 14 feet. Let's figure out how high up he goes at most. So we're going to find the maximum height by finding the vertex. So this is in standard form. We have our equation right here in standard form. A is negative 16, B is 36, and C is 6. We're going to use the vertex formula, which says x of the vertex is negative b over 2a. So in this case, negative 36 over 2 times our a is negative 16. So negative 36 divided by 2 times negative 16 is negative 32. Our vertex is going to be at 1.125, which is really our t value for this one. In general, we solve for x, but this one we have a t as our input instead of an x. So there's the time that he reaches the maximum height, and we're going to plug it into our original formula, s of 1.125. So I'm going to do negative 16 times 1.125 squared plus 36 times 1.125 plus 6. I need to replace all of my t's with 1.125. So we already plugged in time 2, and he was 14 feet in the air. That happened after the max, because the max happened at 1.125 seconds, and we plugged in 2 seconds. He was down at 14 feet after being up at our vertex, which was 26.25 feet. So we have our max height happens after 1.125 seconds. The max height is 26.25 feet in the air for him. Let's convert zucchini's height formula to vertex form. So we know the vertex, we just found it, is 1.125, comma 26.25. There's our h and our k. And we want to remember that A is the same whether you're in standard form or vertex form. So when we do our vertex form, the value for A from above here is going to stay that negative 16. So we have negative 16 times x minus h, or in this case, we're going to have a t, because we're looking at s of t. So we're going to have t minus our h is 1.125. That's getting squared, and then your value for k goes at the end. 26.25 is added at the end. There is the vertex form of this. Keep A the same, still negative 16. Plug in h and k into the specific spots. Now we're going to determine the interval which zucchini's height was increasing. So this negative value for A, whether you're looking at the standard form or the vertex form, that negative flips your parabola upside down. So where are we increasing? The first part is rising or the second part is rising? The first part is rising. We're rising up until we hit our vertex, which is 1.125, 26.25. So we are going to launch at time 0 and keep going up until 1.125, and we never include our endpoints for increasing, because at 0 we're stationary until we're launched, right at 0.001 seconds after launch we've launched. So we're 0 not included till we hit our max height is 1.125, and then we switch. We have that moment where we're at our max, and then we switch to be decreasing. So you never include endpoints for increasing and decreasing. You never have the square brackets ever. So 0 to 1.125, where he hits his max height and then starts returning back down toward the ground. Which sounds scary, but any projectile we can model with this position function or something similar to it to give us the shape of a parabola. We're sending it up in the air, it reaches a max height, and then it comes back down.